Hi there, my name is Jeremy Krug, and I've enjoyed reading the comments and questions so many of you have posted on my AP Chemistry 2023 free response answer videos. Some questions have been popping up quite a bit, so I wanted to post my very first FAQ over the FRQ video. I hope you like it, and I hope it answers some of the questions you might have about the 2023 AP Chem exam. As always, if you can hit that thumbs up button, I would really appreciate it. The very first part of the very first question was a fairly simple electron configuration question. The question asked for the complete electron configuration of manganese, so this is what I put. Roberto Moreno asked a very good question. Does it matter if I put argon in the configuration? And I wasn't sure about that since the question asked for the complete configuration. I wasn't sure if the College Board would take the noble gas abbreviation. I looked into this a little more, and last year's exam, 2022, asked almost the identical thing. When they asked for the complete electron configuration of an element, they did indeed accept the noble gas abbreviation. So I feel pretty confident that if you put argon 4s2 3d5, you will get the point. And just so you know, the 3d5 can go before the 4s2. Both are considered correct. So very good question. Tada Slime asked another question. Can you do the multiple choice questions too? Unfortunately, College Board doesn't release those. Since I can only work problems that they've made available for public release, the multiple choice questions will probably forever be lost in the ether. Number 1, part F, was the galvanic cell question. Here's the overall balanced equation, and then in part F4, it says the student claims that the total mass of the battery decreases because the anode loses mass. Do you agree? And my answer was that the law of conservation of mass tells us that we shouldn't gain or lose any mass, so as long as we have a closed system here, the battery shouldn't lose any mass at all. And I also added that if the anode loses mass, well, the cathode would have to gain mass. C.J. Alborn commented that the anode doesn't really lose mass at all, since the zinc metal is being oxidized into zinc oxide. So in this case, the anode is actually gaining mass. And that is an excellent point. This particular battery is a little different from the galvanic cells we usually study in AP Chem, where there's one metal being oxidized into aqueous cations and aqueous metallic ions being reduced into a metal on the other side. We don't really have that here, as all of the reactants and products are solids. So it would have been more accurate if I had said that the mass of elemental zinc at the anode is decreasing since it's being oxidized into ionic zinc. Either way, it does look like the law of conservation of mass is the key idea here. So very good catch, C.J. Alborn. Excellent comment. 3, Maury asks, why are those questions not like mine? Well, the College Board administers several forms of the AP Chemistry exam each year. The main form is the one that gets released online to the public, and that's the one I have access to. There's another form that's completely different. There's a form for Alaska and Hawaii, a form for students outside North America, a form for the late exam date, and those other forms normally don't get released. Then we have question 3F, the calorimeter question. So a student sticks a thermometer into a coffee cup calorimeter over the course of a reaction, and the chart shows the temperature is going up. So I said the reaction is exothermic. Several folks disagreed. Abraham Borst stated that the problem specifically said that the student recorded the temperature of the system. So if the system is getting warmer, then it's absorbing heat and must be endothermic. And Abraham's comment is based on some good thinking, but there's a little flaw here. I actually think the College Board probably used some poor word choice here. When they said they recorded the temperature of the system, what they really meant to say was they recorded the temperature of the solution, as shown in the first row of the table. The word system specifically refers to only the molecules or particles that directly participate in the reaction. The calorimeter, even the water in the cup, apart from the few water molecules produced in the reaction, That's all actually part of the surroundings. So we're actually taking the temperature of the surroundings. And since the surroundings are getting warmer, the molecules in the system are actually losing heat, which is why the reaction is exothermic. So Abraham made a very good observation, but the reaction is exothermic, and I stand by my answer. Number 6 was an intermolecular forces question, and 6a asked us to list all the intermolecular forces present in HBr and HF. And for HF, I listed London dispersion forces and hydrogen bonding. D. Crimes asked if it's okay to list dipole-dipole along with the other two forces. And I don't see why that would be a problem, since technically hydrogen bonding is a very specific type of dipole-dipole force. So your answer should be fine. Now, if you only listed London dispersion forces and dipole-dipole, I don't think that would be enough, since you need to know that the presence of a hydrogen-fluorine bond indicates hydrogen bonding. Part C of that same question asked us to explain why the bond length in H and Br is greater than the bond length between H and F. My answer involved the fact that bromine has 2 additional occupied electron shells. And since those valence electrons are farther away from the nucleus, the bond length is higher for hydrogen and bromine than it would be between hydrogen and fluorine. Risch asked if an answer that references electronegativity would be acceptable. I don't think that answer would get the point, mainly because electronegativity is simply another effect of fluorines having fewer electron shells. Electronegativity by itself doesn't really explain why the bond length is shorter or longer. So good question, Risch. I try to respond to all the comments that you post, so if you have a question or think I made a mistake, please post it in the comments and I'll do my best to respond. This summer, I'll be working with small groups of new AP Chemistry teachers, traveling to their schools and helping them get started in teaching this fascinating course. So maybe I'll be somewhere near you this summer. Thanks for watching, and I hope to see you again soon.